All right, so now that we know how to find the GCF, we're actually going to be doing something with that. So let's look at the problem we had at the beginning of class. I asked you to look for two polynomials that we could multiply together that would give us 2x squared minus 6x. Now before we go back and look at what our answer was, what is the greatest common factor of 2x squared and 6x? Okay, looking at numbers first, they both have a 2. Then looking at variables, they each have an x. So the greatest common factor is 2x. Now the way that one of the answers that we thought of at the beginning of class was that 2x squared minus 6x is equal to 2x times x minus 3. Now it's absolutely not a coincidence that that first polynomial is the greatest common factor. That's what we're going to be doing. So when you're factoring out the greatest common factor, you first of all find the greatest common factor. That gives me the 2x, but I'm not done. I'm only halfway done once I have the 2x. Then I need to say, okay, if I factor out the 2x, what would be left behind from the first term? So looking at 2x squared, if I take out the 2 and I take out one of the x's, the only thing left behind would be an x. That's why the first term in that set of parentheses is an x. Now looking at negative 6x, if I factor out a 2, I'd be left with negative 3. Then I factor out the x, so the only thing left is negative 3. So my greatest common factor goes in front of the parentheses, and all the leftovers go inside the parentheses. So let's look at a few examples. So again, these are very similar. These are the same terms that we had before. We've just joined them together in an expression using the plus and the minus. So we have 8x squared y. Remember that the parts that make up 8x squared y are 2 times 2 times 2 times x times y. You don't need to write that out, but if it's helpful to think of it that way, then please do. Then 6xy cubed. 6 is 2 times 3, x, and then 3 y's, and then minus 4x, so that's 2 times x. My greatest common factor, we did that in the last video, is 2x, because each of those have at least one 2, and each of those terms have at least one x. Now I'm not done. I found my greatest common factor, but I want to factor it out. So if I pull 2x out of the first term, if it's helpful, look at how that first term is broken up. It's got 2, 2, 2, xx, and y. If I take out a 2 and take out an x, what's left behind? Well, I'd have two 2's, so I'd have 2 times 2, which is 4, and then just an x and a y. That's what would be left behind if I take 2x out of the first term. Now from the second term, if I take out a 2 and take out an x, I'd still have the 3, and then I'd have 3 y's. So I'd have 3y cubed would be left behind from the second term. Now if I take out a 2x from the 4x, I take out a 2, I take out an x, the only thing left behind is just a 2. Alright, how would I check to make sure that I did it right? Now this check is one that I beg everybody to do, but I know a lot of people don't take the time to do it, but it really will help. If you'll just take a second and multiply back through, if you'll just even do it in your head, I promise it'll take you about 1.3 seconds. It doesn't take long. Say 2x times 4xy, 2 times 4 is 8, yep, that works. X times x is x squared, y, so the first term matches perfectly. Then 2x times 3y cubed, 2 times 3 give me 6, then the xy cubed, that matches perfectly. Then 2x times negative 2, that also gives me negative 4x. So just take a second and mentally go back through and distribute it to make sure you've done it right. Okay, now let's look at this one. Remember, we found the greatest common factor in the last video. Each of these terms has at least a 3. Each of the terms has at least one x. And each of the terms has at least 2 y plus 1's. So my greatest common factor is 3x times y plus 1 squared. That's what I'm going to pull out of each of the terms, and then I'll put the leftovers in a big set of parentheses. So if I pull out a 3, pull out an x, and pull out 2 y plus 1's from the first term, the only thing left is a 3. Good. Now for the second term, pull out a 3, pull out an x, so that I'm just going to have a 2 left, I'm going to have an x left. I pull out 2y plus 1, so I'm going to have 2y plus 1's left. So that first term in the big set of parentheses is a 3. The next term in the big set of parentheses is 2x times y plus 1 squared. Okay, for the next one, I pull out a 3, pull out an x, so I'm left with 2 times 2, and then 3 x's, so that's 4x cubed. Pull out 2 of the y plus 1's, so I'm left with 1 y plus 1. And that is how we factor out the greatest common factor. Okay, place to be careful. I know that it's not overly comfortable to look at those y plus 1's and say, oh, this has 2y plus 1's. The next term has 4y plus 1's, and the next term has 3y plus 1's. But it's for a very specific reason that I want you to get used to thinking of a binomial as something in parentheses, just as a normal thing. It's a chunk. It's just like a variable. Like if you, instead of y plus 1, if you just wrote a z, you need to get used to being able to factor out a binomial, because we will be doing it for a very specific reason when we learn grouping. Okay, so this is our factoring strategy. We'll factor out the greatest common factor. That will always, always, always be the first step. Then we'll look at how many terms there are. If there's 2 terms, we'll do special forms. That's one of our last lectures. 3 terms, we'll do special forms. Again, that's lecture 25. Or we'll do the AC method or the diamond method. That's lecture 24. Or we'll do guess and check. That's lecture 23. If there's 4 terms, then we'll do grouping. We're going to learn that in this lecture. That will come at the end of lecture 22. Then we'll see if there's any further factoring. That will be lecture 25. And we can always check our answer by multiplying.